What's up guys? Welcome back to my YouTube channel, and for today's vid, I will be doing the summary of the chapter 6. So if you want to learn something about me, and if you want to get some information about the chapter 6, so stay tuned, and I'll be back guys. Okay guys, so for our 6th video in the summary of the chapters, so the chapter 6, the network layer. So the network applications and services on one-end devices can communicate with applications and services running on another end device. So how is the data communicated across the network in efficient way? So the protocols of the OSI model network layer specify addressing and process that enables transport layer data to be packaged and transported. So the network layer encapsulation enables data to be passed to a destination within a network, so or on another network with minimum overhead. So this chapter focuses on the role of the network layer. So it examines how it divides networks into groups of hosts to manage the flow of data packets within a network. So it also covers how communication between networks is facilitated. So this communication between networks is called routing. So the network layer. The network layer, or OSI layer 3, provides services to allow end devices to exchange data across the network. So to accomplish this end-to-end transport, the network layer uses 4 basic processes. So the first one is addressing end devices. So end devices must be configured with a unique IP address for identification on the network. Then the second one is the encapsulation. The network layer encapsulate the protocol data unit, or the PDU. So from the transport layer into packet, the encapsulation process adds IP header information, then such as the IP address of the source or sending and destination or the receiving host. So the third one is the routing. So the network layer provides service to direct packets to a destination host on another network. So to travel to other networks, the packet must be processed by a router. So the role of the router is to select the best path and direct packets so toward the destination host in a process known as routing. A packet may cross many intermediary devices before reaching a destination host. So each router a packet crosses to reach the destination host is called a hop. So the last one, or the fourth one, is the encapsulation. So when the packet arrives at the network layer of the destination host, the host checks the IP header of the packet. If the destination IP address within the header matches its own IP address, the IP header is removed from the packet. After the packet is then encapsulated by the network layer, the resulting layer for PDU is passed up to the appropriate service at the transport layer. So unlike the transport layer, or the OSI layer 4, which manages the data transport between the processes running on each host, network layer protocols specify the packet structure and processing used to carry the data from one host to another host. So operating without regard to the data carried in each packet allows the network layer to carry packets for multiple types of communications between multiple hosts. So the host forwarding decision. Another role of the network layer is to direct packets between hosts. A host can send a packet to, first one is for itself. A host can ping itself by sending a packet to a special IPv4 address of 127.0.0.1, which is referred to as the loopback interface. So pinging the loopback interface tests the TCP or the IP protocol stack on the host. So the second one is the local host. So this is a host on the same local network as sending host. The hosts share the same network address. And the third one is the remote host. this is a host on a remote network and the hosts do not share the same network address. So whether a packet is destined for a local host or a remote host is determined by the IPv4 address and subnet mask combination of the source or sending device compared to the IPv4 address, the subnet mask of the destination device. So in a home or business network, you may have several wired and wireless devices interconnected together using an intermediate device, so such as a LAN switch and or a wireless access point or the WAP or the WAP. So this intermediate device provides interconnections between local hosts on the local network. So local hosts can reach each other and share information without the need for any additional devices. So if a host is sending a packet to a device that is configured with the same IP network as the host device, the packet is simply forwarded out of the host interface. So through the intermediate device and to destination device directly. Then of course, in most situations, we want our devices to be able to connect beyond the local network segment. So such as out the other homes, businesses, and the internet, devices that are beyond the local network segment are known as remote host. So when a source device sends a packet to a remote destination device, then the help of routers and routing is needed. The routing is the process of identifying the best path to a destination. So the router connected to the local network segment is referred to as the default gateway. So a router is a computer. There are many types of infrastructure routers available. In fact, Cisco routers are designed to address the needs of many different types of business and networks. So the first one is the branch. The branch is the teleworkers or the small businesses and medium-sized branch sites include Cisco integrated service routers or the ISR and the G2, the second generation. And the second one is the WAN or the wide area network. So large businesses, organizations, and enterprises include the Cisco Catalyst series switches and the Cisco aggregation services routers or the ASR. Whose service provider, large service providers include Cisco ASR, Cisco CRS-R3, and the carrier routing system and the 7600 series routers. So the focus of CCNA certification is on the branch family of routers, and the figured and regardless of their function, size, or complexity, all router models are essentially computers. So just like computers, tablets and smart devices routers also requires. The first is the central processing units or the CPU. Then the next one is the operating system or the OS. And also the last one is the memory consisting of random access memory or the RAM, the read-only memory or the ROM, and the non-volatile random access memory or the NVRAM and flash. And the next one is the basic switch configuration steps. So Cisco routers and Cisco switches have many similarities. They support similar operating system, support similar command structures, and support many of the same commands. So in addition, both devices have identical initial configuration steps when implemented in a network. So the default gateway for a host. So for an end device to communicate over the network, it must be configured with the correct IP address information. So including the default gateway address, default gateway is only used when the host wants to send a package to a device on another network. So the default gateway address is generally the router interface address attached to the local network network of the host. So the IP address of the host device and the router interface address must be in the same network. So the default gateway for a switch, typically a workgroup switch that interconnects client computers in a layer 2 device. As such, a layer 2 switch does not require an IP address to function properly. So however, if you wish to connect to the switch and to administratively manage it over multiple networks, you will need to configure the SVI with an IPv4 address, subnet mask, and the default gateway. So that is the chapter 6, the network layer. And I hope you guys get some informations about the chapter 6, the network layer, and I hope you got some informations, and I hope you learned something from me. And for my next vid, I will be doing the summary of chapter 7. So please click the like button and subscription button and the turn bell down below. So thank you guys for watching, and that's all.